Okay, welcome everyone. This is 6.3 on trigonometric functions of angles. So what we know so far is if this is the angle in question, the side opposite that angle is called the opposite side. The longest side is your hypotenuse, and the side next to that angle is your adjacent side, right? So we know those labelings. And we know all the six trig functions: sine equals opposite over hypotenuse, cosine equals adjacent over hypotenuse, and tangent equals opposite over adjacent. And the other three are the reciprocal values of those three. But now what we're going to do is put this in terms of a circle. Okay, so if there's a circle like this, right? And we have in standard position of an angle is it starts off with the positive x-axis as our initial side. And if I'm drawing this angle here, theta, this would be my terminal side, right? Okay. And then in this circle, we can make a right triangle. In any angle, we can make a right triangle that is made up of an x-axis, the hypotenuse will always be called the radius because that's the radius of the circle. And the y is just the perpendicular distance to the x-axis, okay? So if we have this angle here in standard position, again, it's the positive x-axis we start off at. And I want this angle, let's label that angle as 135 degrees. Okay. What's cool about this, and I finish out the angle like this with my terminal side, right? What's cool about this is the six trig function of 135 degrees is the same as the right triangle here in red. So I take that point, right? This point here that's on the circle. I drop it down to my perpendicular x-axis. And I make a right triangle here. Okay. So if that's 135 degrees, the yellow angle, what is this angle here? 45. And we know those trig ratios, right? It's going to be 1, 1, square root of 2. So we can get the six trig functions here, right? That will equal the same six trig functions of 135 degrees. Does that make sense? Yeah, the six trig functions of a 45, 45, 90 triangle in my second quadrant. This is quadrant 1. This is quadrant 2. This is quadrant 3. This is quadrant 4. Is the same as the six trig functions of 135 degrees. Okay? And you guys see these four triangles? These are the only four triangles that we are going to be working with. They're called the reference triangles. Okay. So we're going to be dealing with that soon with our examples. So just take note of that. The reference angle is if we let theta be the angle in standard position, the reference angle is the acute angle formed by the terminal side and the x-axis. Okay, so it'll always be the terminal side with the x-axis. Okay, so notice that all of these triangles here have the x-axis included. Okay, and the y would be the perpendicular distance to the x-axis. All right. Now, if that is the case, our old labeling, opposite, adjacent, hypotenuse, we can turn those opposite, adjacent, hypotenuse in terms of y, x, and r. R being the radius of the circle, y being the y coordinate, and x being the x coordinate. Okay? So notice that if I take this triangle here, right, and I plop it on here, the opposite side would be the same as my y. The hypotenuse will be the same as my r. And my adjacent side would be the same as my x. Okay, in any of these triangles, in any of the quadrants. Okay, and again, the quadrants, if you guys don't remember, this is quadrant 1, this is quadrant 2, this is quadrant 3, this is quadrant 4. All right. So if I get my 6 trig functions, sine is going to equal opposite over hypotenuse, but now it's going to be y over r, right? Cosine, which is adjacent over hypotenuse, is now going to be x over r. Tangent, which is opposite over adjacent, is y over x. Okay, we're just switching the labeling. All right, that's all we're doing. Cosecant now is the reciprocal of sine. Secant is the reciprocal of cosine. Cotangent is the reciprocal of tangent. All right, just flipping sine, cosine, and tangent, right? Or taking the reciprocal of that. Okay. So here are those are the general notes of today, and we're going to jump into some examples. We're going to find the sine of 240 degrees. Your first step here, always, and I'm going to repeat it throughout this whole unit, is to draw out the triangle. Okay? So I have my x-axis and my y-axis. In standard position, 240 would be with my positive x-axis to start. And then since it's positive, I'm going counterclockwise. That's 180. So it would be here like that, right? That would be 240 degrees. Okay? And that's how we would draw out 240 degrees. And then if I get any point along the terminal side, I drop this perpendicular distance to the x-axis. That's my reference triangle. Okay? So there's my 90 degrees, because it's perpendicular. What is this angle here? 60, right? 60 degrees. So this has to be 30 degrees, right? It's a 30, 60, 90 triangle. So opposite to 30 degrees is, what's the ratio of the sides? Opposite to 30 is 1. Opposite to 60 is square root of 3. Opposite to 90 is 2. Okay, so you guys see this triangle that we made in red? Yeah. And that's the triangle that we're going to be dealing with. Okay. So the sine of 240 is the same thing as the sine of 60 degrees in quadrant 3. Okay. So what's the sine of this triangle? Oh, wait. Before we get to sine, reason why quadrant 3 is so important is because from the origin, I went to the left, correct? Yeah. So that 1 is actually what? It's actually -1. And I went down to square root of 3, right? Down square root of 3 to get my y value, right? So that square root of 3 is actually also negative, right? Where my x's and my y's in quadrant 3 are both negatives. So now, what is the 60-degree angle? What's the sine of 60 degrees in quadrant 3? Square root of 3 over 2. Yes. It's the square root of 3 over 2. So that is equal to the sine of 240 as well. That makes sense? That we're going to be dealing with these triangles throughout. Okay? All right. So let's get the cotangent of 495. The first step would be to draw it out. Draw out 495, which would be 360. 360 plus 90 is 410, right? 360 plus 490, or 360 plus 90 is 450. 450 plus another 90. No, right? So it's in my second quadrant, correct? That was actually another 45 degrees. So there's my angle, right? In standard position, right? So that is 495 degrees. So I pick a point along my terminal side, drop that down to my x-axis, the perpendicular distance. So if that's 495, what is this angle here? 45? So that has to be 45 as well. What's the ratio of a 45, 45, 90 triangle? 1, 1, 1, 1, square root of 2, right? Yeah. If you don't know, we got to memorize these triangles. Okay, it has to go like this, right? That's the first step, to memorize those triangles. Okay, so if it's 1, 1, rad 2, but I'm in my second quadrant, so my x value here is negative, right? Negative, positive. And my radius, class, since the radius of a circle It's measuring the center point of a circle to the outside of the circle, right? To the circle itself, right? And that distance is a distance. It's always going to be positive. Okay, so you don't have to worry about the radius being positive or negative. It's always positive because the radius is an actual distance, right? It's an actual length of something. So that's 1, 1, -1, -1, -1, +1, and then square root of 2. The cotangent of 495. Cotangent I know is x over r or x over y, right? So my x value is -1. My y value is 1. So that would equal -1. Cool. All right. Next one is here, cosine of -pi/4. Now, that one is in radians, right? We also have to memorize the special right angles, okay? We have to memorize how to go from degrees to radians, and we start off at 180 equals pi. Okay, if 180 equals pi, then 90 equals pi over 2. If 90 is pi over 2, then 45 equals pi over 4. Half of 90 is 45, or a fourth of 180 is 45. So a fourth of pi is pi over 4. If 180 equals pi, then 60 is going to be pi over 3 because 60 is a third of 180, right? And the last one is 30, which is pi over 6. Okay? If you guys just memorize this, right? It's going to be easy for you guys to go from degrees to radians and radians to degrees. Okay? So the cosine of -pi/4 is the same thing as cosine of -45. Okay, so if I draw that triangle out, that's going to be in standard position. It's negative, so it's going this way, 45 degrees, right? So I pick a point, go to my x-axis, draw that perpendicular distance, and I know that this is 45 degrees. This is also 45 degrees. I know the ratio is 1, 1, square root of 2, positive x, negative y. So that's a negative right there. So those are my side lengths, right? And my r is always positive. So if I want the cosine of this triangle, which is -pi/4, it's going to be x over r, which is 1 over square root of 2, or square root of 2 over 2. Okay? And I promise you, however difficult a problem is going to be from now on, this is what you're going to do. Okay? Whenever you guys come up to me and ask me about a problem that's difficult, I'm going to say, did you draw it out? Yeah. Did you guys do this? Because this is the beginning. And it all builds from here. Okay? Secant of 16 pi over 3. we can turn that into degrees right off the bat. I can write 16 pi over 3 as 16 times pi over 3, correct? That's the same thing, right? 16 pi over 3 is the same thing as 16 times pi over 3. What's pi over 3? 60 degrees. So if I turn this into degrees, it will just be 16 times 60. And 16 times 60, 960. Yeah. So we're getting the secant of 960 degrees. Another way we can think about this is leave it in terms of 16 over 3 and turn this into a mixed number. Why would I want to turn it into a mixed number? What is 360 degrees equal to in terms of radians? 2 pi, right? So if I turn this into a mixed number, which would be 3 5 pi, 5 and 1/3 pi, right? 5 and 1/3 pi, that would be 5 would be 2 pi and another pi, correct? So if you think about it like that, and I draw it out, two pi, 2 pi, oops, turned into a circle. 2 pi, 4 pi, 5 pi. Simple, right? And another third of a pi, which is 60 degrees. That's the angle there in standard position, right? So that is 16 pi over 3 or 960 degrees. Okay. So with this angle, pick a point, drop it all the way down, get the perpendicular distance. And then get this triangle that we're going to be dealing with. Okay. What is the angle? What's my theta in this triangle? 60. So that's 60 degrees. That's 60 degrees. So this has to be 30 degrees, right? So in a 30, 60, 90, what's the ratio of the sides? 1, square root of 3, and 2. I went, or negative x, negative y, and my r is always positive, right? So I got that, and I want my secant. Secant, we can think of it as one of two ways, the reciprocal of cosine, or r over x, which is 2 over negative 1, which is negative 2. Yeah, and then whatever trig function I give you, cosine, sine, tangent, cotangent, cosecant, we can base it off of this triangle. Okay? Make sense? Questions? Here are some identities. No. Here is the reciprocal identities, right? Cosecant is 1 over sine. Secant is 1 over sine. Cotangent is 1 over tangent. The reciprocal identities is easy, right? The first three. These guys here are what we know so far. These two, the tangent and cotangent ones, I'm going to show you how that works. Tangent of theta equals sine theta over cosine theta, right? Tangent, we know, is y over x, correct? We know sine is y over r, and cosine equals x over r, right? So if I turn this into y over r over x over r, this is going to be y over r times r over x, right? Because we're dividing two fractions. So we take the reciprocal of our denominator. And it so happens when we do that, these r's cancel out. And we're left with y over x, which is tangent. Okay, so that's how that works. Okay. And then the cotangent is just the reciprocal of that. So if tangent is sine over cosine, cotangent is cosine over sine. Okay, taking the reciprocal of tangent. Pythagorean identities, I'll cover later. All right. Okay. Here's an example. If tangent of theta equals 2 over 3, and theta is in my third quadrant, find cosine of theta. The first step would be to draw it out. Okay, so I have my positive x-axis of my initial side, and I want quadrant 3. So I want that, right? That's an angle in quadrant 3. I don't know what that angle is, but I know that angle is in quadrant 3. So from here, I'm going to pick a point, drop that down to my x-axis, and that's my reference triangle, right? And then here, it says tangent equals 2 over 3, right? Tangent is y over x, so that's 2 over 3. But since that is in the third quadrant, I know that x is negative and y is also negative, right? So in order to get my hypotenuse of this, I'm going to use a squared plus b squared equals c squared, or Pythagorean theorem. I'm going to put a, b, and c in terms of x, y, and r. Okay? So x squared is negative 3 squared plus y squared is negative 2 squared equals r squared. 9 plus 4, which is 13, equals r squared. So r is the square root of 13. So to find the cosine of that, cosine of theta equals x over r, which is negative 3 over square root of 13. Rationalizing my denominator, That's my answer. Make sense? Yeah. Okay. All right. And that's it for now for this video. Part 2 is going to come up right now. So go to my next video to see other examples.